They say don't reinvent the wheel, but have you ever wondered how it's actually made? That sleek metal circle that keeps your car rolling isn't just a chunk of aluminum. It's the result of fire, force, and precision engineering. From flat, unassuming sheets of metal to the perfectly round rims you see on the road, this is a story of transformation that would make even alchemists jealous. So, how do we turn cold, hard metal into something that looks like art and spins at 100 kilometers per hour without flying apart? Let's roll right into it. Chapter 1. Raw materials. It all begins with aluminum. Lightweight, strong, and surprisingly humble. Most wheel rims today are made from aluminum alloys, and there's a good reason for that. Compared to steel, aluminum is 1/3 the weight. That means your car can move faster, handle better, and use less fuel, or electricity if you are Team EV. But aluminum wasn't always the go-to choice. Back in the early 1900s, most wheels were made from wood or steel. The move to aluminum was a total game changer. It's not just lighter, it also resists corrosion. You don't want your wheels rusting off mid-trip, right? This aluminum alloy usually contains a mix of other materials like magnesium, silicon, and copper, kind of like adding spices to a recipe. Each element changes how the final rim behaves. Magnesium makes it strong, silicon improves the casting, and copper boosts durability. And here's a fun fact. The aluminum used for your rims likely started life as bauxite ore mined in places like Australia or Guinea. That red, earthy rock goes through a process called the Bayer process, where it's crushed, heated, and refined into shiny, pure aluminum. By the time it reaches the wheel factory, it's been melted, purified, rolled, and flattened into massive sheets, waiting for their next identity. Think of it like a blank canvas. Flat, silvery, and full of potential. But in just a few hours, it'll be spun, stretched, and sculpted into something that can carry a car's entire weight at highway speed. Chapter 2. The production process. Step 1. Cutting the blanks. The first step is pretty straightforward. Cutting the blanks. Machines punch perfect circles out of the aluminum sheets, each one about the size of a pizza, or maybe a family-sized pizza if you're into SUVs. These discs, called blanks, are the starting point for every wheel rim. They look simple now, but every curve and contour of a future rim starts here. The precision at this stage is insane. Even a few millimeters off could ruin the balance later. And when you're driving at 120 kilometers per hour, a wobbly wheel isn't exactly what you want. Each blank is then cleaned and checked for tiny imperfections. Only the flawless ones move on, because once we start shaping, there's no turning back. Step 2. Heating things up. Before we start shaping metal, we need to make it behave. Cold aluminum is stiff and stubborn, but heat it up to around 450 degrees Celsius and it becomes flexible, almost like taffy. So these blanks head into massive furnaces that glow like the inside of a volcano. You can actually see the metal change color from dull silver to a soft orange hue. Heating not only softens the aluminum, it realigns the crystal structure, which helps prevent cracks when it's later stretched and formed. It's a delicate dance between temperature and time. Too cold and the metal tears. Too hot and it becomes weak. This is where decades of engineering know-how come into play, and why you don't want to try this in your backyard garage. Step 3. Spin forming. The magic moment. Now comes the real transformation. The part where flat metal turns into something round, beautiful, and perfectly engineered. It's called spin forming, and it's basically blacksmithing meets ballet. The blank is clamped onto a mandrel, imagine a metal cone, and spun at incredible speeds. While it spins, heavy rollers press against it, slowly stretching and shaping the metal outward, forming the basic bowl shape of a rim. Think of it like a potter shaping clay on a wheel, except this clay is hot aluminum spinning at thousands of revolutions per minute. The pressure is enormous, enough to bend solid metal as if it were dough. This process not only forms the shape, but also compresses the metal's structure, giving it exceptional strength and consistency. That's why forged wheels are prized in high-performance cars. They're lighter, stronger, and can take a lot more punishment before cracking. It's mesmerizing to watch. In just a few minutes, that flat disc transforms into a deep, round bowl, the future home of your tires. And here's something fascinating. Even at this stage, every wheel is slightly oversized. That's because later steps such as trimming, machining, and finishing will shave off the excess material to get the rim's shape down to exact specifications. Step 4. Flow forming and strengthening. If spin forming is the sculpting phase, flow forming is the workout. This is where the rim gets its final strength and durability. The wheel blank, now roughly shaped, is reheated again and placed on another spinning mold. Rollers press against the rim's outer edge, stretching it thinner and longer while compressing the metal fibers. This controlled deformation improves the aluminum's grain structure, making it denser and more resilient, just like how forging steel makes it tougher. The cool part? This process gives the rim the same strength as a fully forged wheel but keeps it lighter and cheaper to produce. It's basically the best of both worlds. Strength of a marathon runner, weight of a sprinter. And here's a little known detail. The thickness of the rim is carefully calculated depending on the car's design. Sports cars, thinner but stronger rims for speed and handling. SUVs and trucks, thicker reinforced rims to handle weight and impact. It's precision engineering disguised as everyday hardware. Once the flow forming is complete, the wheels are cooled slowly to maintain internal balance, because cooling them too fast can create internal stress and microscopic cracks. It's wild to think that at this point, each rim has already endured temperatures hotter than lava and pressure strong enough to crush steel. Yet it's still perfectly round, perfectly smooth, and ready for the next stage. Step 5. Machining and detailing. Now that our rim has survived the fire, the pressure, and a metal workout that would make a blacksmith sweat, it's time to give it some personality. Up until now, it's been all strength and structure. But from here on out, it's about style, the part where engineering meets art. Welcome to the machining stage. This is where those rough industrial wheels start turning into the smooth, sleek designs you actually recognize. The ones that make you go, dang, that looks good. Each rim is clamped into a CNC lathe, basically a high-tech sculptor with diamond-tipped tools that can shave off metal with ridiculous accuracy. We're talking fractions of a millimeter here. One wrong move and your perfect wheel becomes a wobbly pizza pan. But when done right, it's poetry in motion. As the tool glides, you can literally see the wheel's character emerging. The curves, the spokes, the edges. This is where design meets precision. Some wheels come out bold and angular, built for muscle cars that look like they bench press sedans. Others are smooth and elegant, like the sharp, polished rims you'd see on a supercar flying down the highway. And then there are the rugged ones, thick, deep-spoked beasts ready for the mud and grit of off-road adventures. But no matter the style, there's one thing every wheel needs, and that's balance. If one side's even a few grams heavier than the other, the wheel can vibrate like a washing machine on spin cycle. That means rough rides, uneven tire wear, or worse, damage to your suspension. And here's a cool little fact. Every single wheel is weighed and fine-tuned down to the tiniest detail, sometimes to 1/10 of a gram. That's about the weight of a paperclip. Now, that might sound a little obsessive, but think about it. When your wheel's spinning thousands of times per minute, that paperclip-sized imbalance can feel like a hammer pounding away. So yeah, from here on out, it's all about precision, balance, and beauty. Because making a wheel isn't just about rolling, it's about rolling perfectly. The rough edges are gone, the design is alive, and the rim finally looks the part. But we're not done yet. Before this masterpiece hits the road, it still needs a touch of shine. Some cutting, drilling, polishing, and maybe even a color coat to match its attitude. Because every great wheel deserves a little glamour after all that grind. Step 6. Polishing and finishing. Now that the rims are shaped and balanced, it's time to make them shine. And no, we're not just talking about a quick wax. Polishing is an entire process of its own, involving multiple stages of grinding, buffing, and cleaning. First, the rough edges are smoothed out using fine abrasives. Then, automated arms equipped with buffing wheels and polishing compounds start giving the rims that mirror-like sheen. If you've ever seen a brand new wheel sparkle under sunlight, that's the result of hours of polishing, sometimes using compounds made from ground pumice or aluminum oxide. At this point, every tiny scratch, swirl, or smudge is eliminated. The result? a surface so smooth it reflects light almost like chrome. But not every wheel ends up shiny. Some are designed for a different kind of finish: matte black, gunmetal gray, or even candy red. That brings us to one of the most colorful stages in the entire factory. Step 7. Coating and painting. This part feels like a crossover between science and art class. Rims roll into what's called a powder coating booth, a high-tech chamber where color comes to life. Instead of using wet paint, the factory uses electrostatic powder coating. Here's how it works. A fine powder, made of pigmented resin, is sprayed onto the rim's surface. The powder particles are electrically charged, while the rim is grounded. The result? The paint clings perfectly, wrapping every curve evenly like static cling but way cooler. Once coated, the rims go into an oven, where the powder melts and fuses into a single flawless layer. The temperature? Around 200 degrees Celsius, roughly the same as baking a pizza. And honestly, if you've ever seen hundreds of bright wheels baking in an industrial oven, it's oddly beautiful, like a gallery of metallic donuts. This baked-on coating protects against corrosion, scratches, and the general abuse wheels go through, from road salt to curb kisses. And for premium finishes, some rims even go through a clear coating stage, adding that extra layer of shine and durability. Some factories take customization to another level, offering dual-tone designs where machines precisely mask and polish specific areas, creating a contrast between matte and glossy surfaces. It's subtle, but it's the kind of detail that makes people turn their heads at a stoplight. Step 8. Assembly and hole drilling. Next, the wheels are prepared for assembly, the part that connects your ride to reality. Drilling machines bore the center holes and the lug nut openings. These have to be perfectly aligned to ensure the wheel fits snugly onto the vehicle hub. If a hole is even a hair off, the wheel won't mount correctly, and that could spell disaster. Here's a cool detail. For multi-piece wheels, the kind used in racing or luxury cars, the assembly is even more intricate. The rim, barrel, and face are produced separately, then bolted together using precision-engineered fasteners. It's like assembling a Swiss watch, but one that carries a 2-ton car at full speed. Before moving to quality control, every single wheel is cleaned again to remove oil, dust, and microscopic particles. You'd think it's excessive, but any debris left behind could affect the coating or balance. When a product spins at thousands of RPMs, close enough simply doesn't exist. Chapter 3. Quality control and testing. At this point, the rims look perfect, but looking good isn't enough. Now they have to prove they can handle real-world punishment. Factories put every wheel through brutal tests. There's the radial fatigue test, where the wheel spins under heavy loads for hundreds of hours to simulate years of driving. Then the impact test, where it's literally dropped against a steel block to mimic potholes. And finally, the cornering fatigue test, where the rim is twisted back and forth thousands of times to ensure it won't crack under cornering forces. In other words, it's a gym day that never ends. Only wheels that pass all tests move on to packaging. The rest, recycled. In fact, most factories melt down any defective rims and reintroduce the metal into production. Zero waste. And here's something most people don't know. A single wheel can go through up to 50 separate inspections before it's approved. Everything from thickness and hardness to coating adhesion is checked, logged, and signed off by an engineer. It's perfectionism at an industrial scale. And after all that, the wheel is finally ready to roll, quite literally. Chapter 4. The final product and what happens next. Once the wheels pass inspection, they're laser etched with batch numbers and serial codes, kind of like a birth certificate for every rim. That way, factories can trace where and when each one was made, in case there's ever an issue down the line. From there, they're carefully packaged, stacked, and shipped off to car manufacturers, dealerships, or straight to the aftermarket for enthusiasts who want to customize their ride. And here's a fun twist. Some high-end brands actually treat their wheels as collectibles. Limited edition rims designed for special models can sell for thousands of dollars. And yes, there are people who display them like art. And honestly, when you realize how much precision and craftsmanship go into making one, it kind of makes sense. So the next time you glance at your car's wheels, remember this. What started as a flat, silent sheet of aluminum has been through fire, pressure, and the kind of precision usually reserved for spacecraft. All just so your car can roll smoothly down the road. It's strength, science, and a little bit of art all spinning in perfect harmony. And if you thought this was cool, just wait till you see how the tires that sit on those rims are made. That's a whole other story, one that's got even more twists and turns. If you enjoyed watching metal go from flat pancake to road royalty, go ahead and give that like button a little spin. It helps more people join the ride. Also, click the subscribe button because we've got plenty more transformations coming your way.